We are going to be working on prime factorization. Let's talk about what this means. Factorization means to break a number into factors. Factors are numbers that multiply. So for example, the number 15, the factors are 5 and 3, right? These are the factors over here because they multiply to make 15. So the factors of 15 are 5 and 3, and also 1 and 15, right? So if I wanted to list all the factors of 15, that would be 1, 3, 5, and 15. These would be all the factors. Okay. Now, prime, because we're doing prime factorization, prime means only divisible by 1 and itself. Okay, so for example, the number 5 is prime because its factors are only 1 and 5. There's no other factors of 5 because it's prime. It's only divisible by 1 and itself. We're going to go through the numbers up to 20 and just list whether they're prime or not prime. And it'll just be convenient to kind of have a list and also to kind of think through like, oh, why is that number prime? Why is that number not prime? So we're actually going to start at 2 because it doesn't make sense to think about the number 1. The number 1 is divisible by 1 and it's divisible by itself. Those are the same things, but we don't really consider it prime particularly. Like it's not really prime or not prime. By the way, the word for not prime, the official word for not prime is called composite. Not super important, but there it is. Okay, so is 2 a prime number? It's only divisible by 1 in itself. Yes, it is prime. And it happens to be the only even prime number because after 2, any even number, 4, 6, 8, 10, those numbers are all divisible by 2. So therefore they are not prime because they are not only divisible by 1 in themselves. Okay, 3 is prime because it's only divisible by 1 and 3. 4 is not prime because it can be divided by 2. 5 is prime. 6 is not prime because I can do 3 times 2 and get 6. 7 is prime. 8 is not prime because it can be divided by 2 and 4. Now, you might be tempted to put 9 over here because you may have noticed that these are all the odd numbers. However, 3 times 3 is 9, and therefore it is not prime. Neither is 10 because 5 times 2 is 10. 11, though, is prime because the only thing I can multiply and get 11 is 11 and 1. Okay, 12 is not prime. 6 times 2 is 12. 3 times 4 is 12. 13 is prime. Okay, 14 is not prime. 2 times 7 is 14. And 15 is also not prime, even though it's odd, because 5 times 3 is 15. Okay, 16 is not prime, because 4 times 4, 2 times 8. 17 is prime. I'm running out of space. 19 is also prime. Okay, whereas 18 is not prime, and 20 is not prime. Okay, so nice to just have those lists as you're starting to work on this topic. Okay, now next I'm actually going to show you an example, and then after I show you, we'll talk about like the steps, how to do it, but I think it's kind of just easier to just see. Okay, so I'm going to do the prime factorization of 75. What that means is I'm going to go like this, and I'm going to think of 2 numbers that multiply to 75. And I actually have a couple choices here because 5 times 15 is 75. It's probably not the first thing you think of. What you might think of is, oh, like if I have 75 cents, I have 3/4. So that must mean that 3 times 25, right? 3 times 25 cents is 75. Now watch what I'm going to do. When I get to this 3, I notice, okay, 3 is prime. I'm going to circle it. Okay, and I'm going to stop there. I'm not going to factor any farther. Whereas the 25, I think, is 25 prime? No, it's not. I can multiply numbers and get 25 because I know that 5 times 5 is 25. But when I get to this 5, I say, oh, 5 is prime. Let me circle it. 5 is prime. Let me circle it. And notice, then I stop. Once I get to a circle, I don't continue on that number. Okay, now 75 it's this times this times this. It's 3 times 5 times 5. Okay, and you notice that could be 3 times 25, which is 75. It could also be, look, this is 15. 15 times 5, okay? And either one of those would work as first steps, and had I done 5 times 15 first, I still would have gotten a 3 and 2 5s. Okay, so I listed the factors, and notice that I listed the 5s together. Like, don't do like 5 times 3 times 5, like split up the 2 that are the same. Don't do that. It's just gonna make your life a little bit difficult down the line, okay? So notice I'm going to go through the steps, and then I'm going to do one more example. So you make the tree's roots, right? This is like the tree, and we're making roots by finding 2 numbers that multiply to the number above, right? So 3 times 25. Notice it's not like 70 and 5. Those add to 75, but that's not what I'm looking for. I'm looking for numbers that multiply. Okay, and you stop factoring and you circle when you get to a prime number. Okay, and you're going to see in the next example why that stopping and circling is so important, because it's a really good, important way to prevent mistakes. Let's do 48. So go ahead and you can even pause if you want to have some time to think. Can you think of two numbers that multiply to 48? And if you can't, right, what I would say is the first thing you should think of is like, it's an even number, right? So it can be divided by 2. So you could just go ahead and divide it by 2, right? And then try to think of what it divides by. We're going to talk about divisibility rules in a second, because it turns out it's also divisible by 3. It's also 6 times 8, right? 6 times 8 might be the one that you thought of, but maybe if you couldn't think of any, you were like, all right, let me just divide it by 2, and then you do 2 times 24. Either way, you're going to end up with the same. 6 is not prime because 3 times 2 is 6. Both of these are prime. Okay, and this is 2 times 4. And this is 2 times 2, and these are prime. Okay, so 48 is, look, there's a 3, and there's 4 2s. Again, just group the 4 2s together. Like, you can put them first, you can put them second, doesn't matter, but don't do like 2, 2, and then 3, and then 2, 2. That's silly. It's nice to have the numbers that are the same in a group. So I'm going to do 2 times 2 times 2 times 2, there's 4 of them, times 3. Okay, now you can see here why the circling is so important, and here's why. Because, like, see this 2 right here in the middle? Had I not circled it, it would have been kind of in the middle of this big old tree, and I would probably have missed it, right? Or like occasionally I'll miss a number like that that's kind of in the middle. So the circling helps prevent you from missing numbers. And you can see, like, this 4 is not circled. Why is it not circled? Because it's not prime, and I didn't stop there. So you'll notice I didn't list that 4 here, or this 8, or this 6, or this 25. Why? Because I broke those numbers down further, right? This 8, it's here, it's right here, it's these 3 2s, right? I broke that 8 down into 3 2s. So I'm only listing prime numbers here, I'm only listing my prime factors, okay? And then this one, sometimes you'll get a number like this and you're like, 31, what can I multiply to get 31? And the answer is nothing, it's prime. This is prime, you are done. 31 is just, there's your prime factorization right there, and you're done with that problem, okay? So you'll see numbers like that eventually. Okay, now, a couple just tips here, because sometimes you'll look at a number and you'll be like, oh crap, what can I divide that by? So a couple things to look for. You can always divide by 2 if it's even. Okay, so if it ends with a 0, a 2, a 4, a 6, an 8, those are even numbers like 48, and you can always divide that by 2. So if I was like stuck on 48, I could be like, all right, let me divide this by 2, right? And I would think, okay, well, like half of 8 is 4 and half of 40 is 20, right? And I would have done like that, and then I would have kept going. And you would have gotten the same answer had you done that. Okay, 3. If a number is divisible by 3, if the sum of the digits is divisible by 3. So here's an example. The number 57, you might not think to yourself like, oh, well, of course, 19 times 3 is 57. That's something I know. It's probably not, which is fine. But you can see is 57 divisible by 3 by saying, okay, let me add the digits, right? So the digits are 5 and 7. 5 plus 7 is 12. You can think, oh, okay, well, 12 is divisible by 3. Or maybe you're like total brain fart and you don't remember that. That's fine. You can add these digits, 1 plus 2, it equals 3. So that means that this number is divisible by 3. 48 is also divisible by 3, which you can see here, right? 16 times 3 is 48. So you could have started with 3 and 16 here, okay? And then 5, if the number ends in a 0 or a 5, it's divisible by 5. If it ends in a 0, in fact, it's divisible by 10, right? Like if I see a number like 40, I'm pretty much always going to start with 4 and 10. That's just like the first thing that I think of, right? And there's a lot of possibilities with 40. I could do 5 times 8, I could do 2 times 20, but I pretty much always think if a number ends in 0, that I'm going to start by 10, by dividing by 10. Okay, so right now you're going to pause the video. Okay, so you're going to press pause. You're going to do this problem as a chance to kind of process all the notes, and then you're going to come back to the video, and I'm going to do it. Okay, so pause now. Okay, hopefully it's done on your paper. Okay, like I said, I always like to, when I see a 0, I always divide by 10. It's fine if you didn't. You could have done 5 times 6. That would have worked, right? Totally okay. But I noticed this, so I'm going to do like this, and then I say, oh, okay, 10 is divisible by 5 and 2. And so I get 5 times 2 times 3 equals 30. And you can check. You can be like, okay, 5 times 2 is 10, times 3 is 30. You can also do it the other way. Look, 3 times 2 is 6, times 5 is 30. It should work both ways.